In this video, we're going to look at how to graph linear inequalities on a number line and how to write them using interval notation. The inequalities are less than or equal to, and greater than or equal to. Less than means that a number is to the left of on the number line, and greater than means that a number is to the right of on the number line. We're interested in inequalities that have a variable. X less than 3 means any number that is less than 3. That means any number that is to the left of 3 on the number line. When we graph this inequality, we highlight the interval, the set of all the numbers on the number line, to the left of 3. Since this interval has no lower bound, we use an arrow to indicate that it goes forever to the left. 3 is the upper bound, and because 3 is not included in this set, here we have x is strictly less than 3, we use a round or open bracket to indicate that this number is not included. When we write this using interval notation, we use a pair of values that indicates the lower bound and the upper bound of this interval. Since this interval goes forever to the left, we write the lower bound as negative infinity, and the upper bound is 3. And just like with the graph, we use a round bracket when the endpoint is not included. Infinity is never included, so we always use a round bracket when we have negative or positive infinity. X less than or equal to 3 would include all the numbers less than 3 or equal to 3. So here we have all the numbers to the left of 3 highlighted on the number line, and we use a square or closed bracket to indicate that the 3 is included in this set. So we will always use round brackets when there is no equals and square brackets when there is an equals. For the interval notation, the lower bound is again negative infinity because this goes forever to the left, and the upper bound is 3, and this time we use the square bracket to show that the 3 is included. Remember, we always use round brackets for infinity. X greater than 3 will be all the numbers to the right of 3 on the number line. So we highlight the interval to the right of 3, and in this case we would use a round bracket because the 3 is not included. Now for the interval notation, 3 is the lower bound, so that number goes first. And because this interval goes forever to the right, the upper bound is positive infinity. And here we use the open bracket for the lower bound because the 3 is not included, and we always use the round or open bracket for infinity. X greater than or equal to 3 will be everything to the right of 3, and the number 3 is included. So here we use the square or closed bracket for this endpoint to show that it is included. And with the interval notation, we also use the square or the closed bracket on this lower endpoint. And we always use the open bracket with infinity. These are examples of unbounded intervals because we go either to positive infinity or negative infinity. Now let's look at an example of a bounded interval where we have a finite value for the lower and the upper bound. Here we have -2 is less than x, and x is less than 5. That means that x is both greater than -2 and less than 5. So this will be all the numbers between -2 and +5 on the number line. Here we've highlighted that interval from -2 to 5, and we're using open brackets on both endpoints because neither of them are included. These are strict inequalities. And the interval notation has the lower bound of -2, the upper bound of +5 with the open brackets. If we replace each of these less thans with a less than or equal to, we get the same interval, but now we've included the two endpoints. So we use the square or closed brackets. and we use the closed brackets for the two endpoints with the interval notation. In the first case, we have an open interval because both endpoints are open, and in the second, we have a closed interval because both endpoints are closed. We can also have half open and half closed intervals. In this case, we have a strictly less than and then a less than or equal to. So half of this interval will be open, half will be closed. Here on the graph, we've highlighted the interval between -2 and 5. We have an open interval on the lower endpoint because that is not included, and a closed interval on the upper endpoint because that is included. And we use the same open and closed brackets with the interval notation. And last, we have a less than or equal to and then a strictly less than, so that the lower endpoint is included and the upper endpoint is not included. So here we have a closed bracket on the left and an open bracket on the right. And the same thing with the interval notation. This covers all of the different types of open and closed intervals and bounded and unbounded intervals. In the rest of this lesson, we'll be solving linear inequalities. We'll have to isolate the variable first. But once we've isolated the variable, we'll have something that looks like one of these examples. So our graph and our interval notation will look like one of these.